Hello, everyone, and welcome to another live episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today we're going to be talking all about how easy it is to write microservices and other kinds of components of your application minimally. So joining me today is the other Richardson in the room, Rob Richardson. Hey, Rob.
Hi, great to be
How you
here.
doing? Nice to see you. Thanks for coming.
Yeah, it's so much fun. We get to code today.
Awesome. We love live coding on this show. So before
Oh
we get
yeah.
into that, yeah, it's good stuff. So before we get into that, can you tell us a little bit about yourself and what we're going to be talking about in a better
Yeah,
summary than what
definitely.
I just gave? Cool.
I'm a developer. I build stuff in .NET and Node, and it's really fun to be able to build these microservices in modern tools. We're going to take a look at a project today that is in .NET 5. We're going to convert it to .NET 8, add a bunch of C# 10, 11, and 12 features, and then add minimal APIs to see how we might be able to build microservices inside of .NET. It's a really fun talk.
Sweet. Yeah, and I think that's great. You've got some migration aspects of things that we're going to
Yeah.
talk about here, which is I know like a roadblock that plagues lots of teams out there who want to make that leap, but just the
Yeah.
mountain of work that can sometimes be associated with migrating and
Yeah.
modernizing your apps can be challenging, right? So that's
And
cool.
time permitting, we'll get to talk about testing as well, which is another thing that, typically when we're thinking microservices, we're like, nah. But testing is really easy inside of .NET now.
Awesome. Well, I'm looking forward to seeing what you got. So before we go into the nitty gritty of things, don't be scared. Feel free to ask any questions that you have about minimal APIs and ASP.NET or anything related to that topic, and we will try our best to answer them. And if you're coming from Twitch right now, I know I think the .NET stand-up is still going, so hang out in YouTube land for a little bit and then trickle into Twitch later. So yeah. So Rob, want to get started?
Excellent.
Cool.
So this is really cool. The code that we'll see is up on GitHub, but let's start with kind of a minimal example. I have here site.csproj, and if I open this up in VS Code, we can see that all we have right now is that csproj. And this csproj is really pretty empty. For the most part, all it says is this is running .NET 8. So let's create a program.cs, new file, program.cs. And I'll say var builder equals web application. And then I'll say var app equals builder.build and app.run. Now, what's my app going to do? Well, let's do this. Let's say app.mapGet, and we'll map our home page to this Lambda function, and we'll return a new object. And let's say we've got a message. Hello world. Well, hello world is a little thank you, null reference types. And so now instead of hello world, let's say hello name. And if you don't pass in one, then I'll say world. Excellent. So now we've got this little minimal program. Let's run it. .NET run. Oh, the other .NET run. .NET run. And it'll take a little bit to wake up the gerbils. But now we'll start up our web server. Now, yeah, my machine is doing streaming and a bunch of other stuff. So your performance will probably be a lot speedier. And I'm waking up the gerbils. So we've got now ready to go. It's hosted on HTTP port 5000. Let's launch HTTP port 5000 and let's take it for a spin. Localhost 5000. Hello world. Let's pull up the developer tools. Take a look at the network tab. We can see that we've got HTTP status code 200. We've got a content type of application JSON. If we pass in a name equals Visual Studio Toolbox, we can see that we get hello Visual Studio Toolbox. We're getting query string parsing. We're still getting our HTTP status code. We've got a full web server in 4 lines of code. That's really cool.
Yeah. Shoot, that was pretty quick. Let's ship it.
Yeah, ship it. This isn't the website that I wrote yesterday in the office. This is, are we in the land of visual Fred again? What is this wizardry? Let's come back to that. Now, if I wanted to come into Visual Studio and scaffold out a minimal API like that, I could come here and create a new project. And once I'm in the new project dialog, I can choose ASP.NET Core Web API. I'll give it a name. And then I have this checkbox right here that says use controllers. If this is checked, I'm using controllers. If this is unchecked, it will scaffold out a minimal API. So that might be a great way to get started with this. But let's get started with this code, and we'll close out this. We'll close out the web server. Excellent. And the code that we'll see today is up on GitHub right now. github.com/robrich/minimal APIs ASP.NET. And we just saw the bare minimum. Next, we'll start with an ASP.NET 5 project. We'll upgrade it to ASP.NET 8, and we'll see each of these features. If that URL is too long, head off to robrich.org, click on presentations, click on minimal APIs with ASP.NET, and the code is available. It is online right now. So let's dig in. We've got this project, and let's start it up, and let's just take it for a spin. This is an ASP.NET 5 project, and it's basically just a template. Mostly. Let's take it for a spin. So here in this application, we do have a home page. We have an about page. We have a weather forecast page. Here's our home page. Here's our about page. Here's our weather forecast controller. We can see that it's got some stuff. We also have a Swagger page where we can try it out. Well, what's cool about this project is that it's really flexing 3 different ASP.NET hosting technologies. So this home page is an ASP.NET MVC controller. Let's come back into that solution. We'll open up that home controller. Here's our home controller. We have an index view. We can pop open their index view, and there's our home page. The interesting thing is that the about page is actually Razor Pages. How did we wire that up? Well, we have here this about view inside of Razor Pages. And our MVC, our weather forecast controller, is this controller right here. Now, how did we wire each of these up? Here inside of startup.cs, we can rig up all the things that we want. So we say add controllers with views. That goes and grabs MVC. And then we down here say map controller route, and that will expose all of our MVC routes available to the internet. So that gets our home controller. Our about controller, well, that's a Razor page. So we say add Razor Pages. And then down here at the bottom, we say map Razor Pages. Now we have Razor Pages. Razor Pages is great for a static website where there isn't very much content between our URLs and our pages. We can do interesting code behind things, and we'll come back to that as well. Then how do we do our web API? Well, we say controllers with views. Web API controllers are controllers, so that rigs up too. What we see here is that they aren't mutually exclusive. We can use all of them in the same place. Now, probably you're not going to use all of them together. That's totally fine. But I wanted to show all of them running together so that we can see how easy it is to upgrade our project from .NET 5 to .NET 8. So let's pop open our CS proj, and I'm going to change 5 to 8. Now, the cool part here is that's all I need to do to upgrade to .NET 8. Now, I definitely could come in here and I could go to the properties and I could choose it from the dialog if I really wanted to. But if you're going to do nothing else, if you get nothing else from this conversation, upgrading to .NET 8 will improve the performance of your website because they've optimized things like span of T and done a whole lot of work to reduce allocations. The Stack Overflow team noticed that when they upgraded to .NET 6, their site just got faster and they didn't do anything else. So we just upgraded to .NET 8. Let's come in here and manage NuGet packages and see if we've got any NuGet updates. And it looks like we do. We have ASP.NET Swashbuckle that will power the Swagger UI. So let's update our NuGet packages. Now it's a good idea to do that periodically. And so we've done it now here in our website, and we see that it updates our site to include the latest version of that package. And
so
now if
on
we
that
fire
topic, real quick, so we can talk about like NuGet packages, but what are some other things that users should look out for when they're migrating? Because, you know, yeah, swapping to .NET 5 to .NET 8, you can definitely see the perks of like from a performance standpoint and things, but are there other like invisible roadblocks that might be worth doing a checklist of before you make that leap or after you make that leap?
When you're moving from .NET to .NET Core, there was a lot of work there. When you're moving from .NET Core 1 to .NET Core 2, there was a little bit more work, a little bit of work there, but starting with .NET 3.1, going all the way up to .NET 8, it's really, really easy to migrate. And so probably you're not going to have any issues at all. Now, you may have concerns if you have a dependency that has maybe a NuGet package that has a dependency on Windows APIs or something like that. So you may be blocked from updating for that reason, you know, dependencies, but probably it's just as easy as I did it. You may have to run through a few things, you know, maybe there's a more modern API for hooking up routes, or maybe there's a different way for doing some of the plumbing behind the scenes. But for the most part, just upgrading from .NET Core 3.1 to .NET 5 to 6 to 7 and to 8 is as easy as I did it. The majority of the projects that I've done it, it's just changing the version number and updating the NuGet packages.
Gotcha. Awesome.
Yeah. So here's our website, and now it's running a .NET 8, and it's doing just fine. I'll hit the About page, the Home page, the Swagger page, try out our API, and yeah, our website works great.
Yeah, looking good.
So now that we're here inside of .NET 8, we have some new C# features that we can take a look at. And so let's start to play with all of those. Close all tabs. Let's pop open homecontroller.cs. Now, the first thing that we're going to take a look at is this namespace. When we start up a C# project, we'll indent our namespace to our class 4 spaces. We'll indent our class to our method 4 spaces. We'll indent our method to our code 4 spaces. We're 12 spaces in and we haven't said anything yet. So wouldn't it be nice if we didn't have to have all this unused white space? Well, it turns out the majority of namespaces apply to the entire file. So we can use file scope namespaces. I'm just going to hit the semicolon key. Thank you, Visual Studio. It's going to automatically remove those curly braces. Yeah. And now I have, yeah, it's magic.
Oh, yeah, I feel like I just
discovered that the entire file.
Gosh, just so much cleaner, less braces. It's great.
Yes. Now, if you do have a generated file that maybe does need multiple namespaces in a file, you can definitely use the old syntax. It's not going away, but this is so much simpler. So let's run around our app using file scope namespaces. Here's this one, and here's this one, and here's this one. And I don't know why the weather forecast model is not in the models folder, but there we go. And this one, and this one. Did I miss any? Namespace.
And fun fact, if you did miss anything, that's when you can use an editor config file. And I believe there is an option in there to set like a warning or an error for that particular formatting, if file scope namespace is what you want, which is nice.
Right.
You can have to yell at you.
But the cool part is the old syntax is not going away. So if you like that, then continue on.
Awesome.
So we can build and run this and it'll work out great. Next up, let's take a look at using statements. We spend so long in code reviews arguing over using statements. You have to remove the unused ones. You have to sort them in this way. Couldn't we just make them go away? Can we just stop arguing about using statements? I'm going to create a new file, and I will call this file usings.cs. Now, there's no official convention here. You might call it global.cs. You might call it usings.cs. You could even put this at the top of another program, another code file. But I'm going to take this using out of here, and I'm going to put it here. And I'm going to say global using site.models. Now, that means that this applies to every code file within the project. I no longer need to define this using anywhere in my project to get this to take effect. Now that can be great. So let's move all of these usings out of here into this global usings.cs. I'll go grab these ones and 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 all of these. And now this is going to be really cool. Let's use a little regex magic to take the beginning of the line and put global space in front of it. There we go. And now all of them are global usings. Oh, I got two. Now the cool part, let's build this, and we can see that it still builds just fine. And now we can be done fighting over namespaces. We can put all of those usings in that one usings.cs, and we don't have to worry about them at all. Now, because there's no official convention here, if you get Visual Studio to automatically add the namespaces for you, you may end up with a few namespaces at the top of your files. Easy enough. Just copy and paste them into your usings.cs file.
Cool. And this using.cs file, it's project specific, or can you make it like solution wide?
You can't make it solution wide, but you can do some tricks like add existing item to be able to have one global usings file for your entire solution that you just happen to add to all the projects. But I tend to find that different projects end up with different dependencies. And so one using per project isn't bad.
Gotcha.
Now the cool part, Visual Studio has highlighted for us some duplicates, this green squiggle. So we can delete all of these. They're already in the file. We can delete all of these. Here's some more that we don't need, some of these. And now we only have 16 using statements in our entire solution. Cool.
Awesome.
Now we only have to argue about 16 things once.
So great. Yep. And there's also keyboard shortcuts for that too, if you're into that. And one comment put yeah, Control K E S. That's a lot, but that can shorten clean duplicate ones too, apparently. And I know there's another one where you can right click on, yeah. And I know you can like right click in a project and ask VS to basically skim through your code and identify usings that you're not using along with other packages and things, and it'll clean that up for you too. So yeah, there's lots of ways to clean up your code, which is great.
So next up, let's talk about implicit usings. Now, isn't there a thing where like Microsoft could just know that certain usings are required?
That would be nice.
If I created a new project in .NET 6, 7, or 8, implicit usings would be here by default. But they don't add it to projects when we migrate it. Because we migrated from .NET 5 to .NET 8, it wasn't there to begin with. Now, the cool thing is Microsoft is going to look at this SDK and look at the usings that are typically in such a project. So I'm going to come here into my source code. We started with the .NET 5 project and kept updating it. So let's come here into debug, into .NET 8, and let's look for globalUsings.g.cs. Now, this is the file that Microsoft will automatically include in our project that it matches our SDK type so that we have these usings in automatically. Now, one of the things that I scratch heads with is here's global and here's global. Why do I have it twice?
Right.
Well, what if I came in here and I said my namespace is site.system? First off, don't. But next, so is this using system the site.system or the global system? And that's why we have this syntax, global : that means it's the beginning of the chain. So start from here. Now, because I'm not going to make this site.system, then I won't need that. But let's temporarily copy this into the top of our file. And now we can see that we've got a bunch more duplicates. Hey, these are already in there because we're using global using implicit usings. We can delete all of these. And now in our application, we have 6 using statements.
So much nicer.
Isn't that clean?
So clean. All in a separate space too. It's great.
Yeah. Now we can definitely argue about whether we should remove this unused one, whether we should sort them, should system be first or Microsoft be first, but we can see that, hey, the build worked just fine.
Yep.
Let me go double check and make sure I didn't leave any usings behind. Nope, it looks good. Cool. So we talked about how we might upgrade our project. We upgraded to .NET 8. We upgraded our NuGet packages. We used a little bit of C# 10 and 11 and 12 syntax. Next, let's take a look at program.cs. Now, as a CS 101 student, you probably learned how to look for static void main. That's the entry point. That's where we go to look for what's happening. And what's happening here? Well, create host builder.build.run. Okay, we have this create host builder and it's doing a whole bunch of, I have no idea. It looks like it's just kind of bootstrapping this startup class. And yeah, startup is where all the magic happens, but it has no static void run, static void main. So let's take a look at this and, well, let's delete that and see if we can use the new builder. So I'm going to say var builder equals web application.create builder. I'm going to pass in my command line arguments and then I'll build IOC container and then var app equals builder.build and set up request pipeline and then app.run. Cool. Now we know what's going on. Okay, we need to do these things. Let's build the IOC container. Well, we have this var startup equals new startup, and it takes configuration. We'll pass in builder.configuration, and then startup.configure services. Okay, it takes in services. We'll pass in builder.services. Excellent. Set up the request pipeline, startup.configure, and that takes in our app and the environment. And now we're using the new builder. I kind of get what's going on now. I understand how this is working. Now, if you like that separation between program and startup, you could definitely stop here. But I kind of really want to see all the pieces. So I'm actually going to pillage startup and put it into place in program.cs. So let's go grab that. Now, I could say var services equals builder.services here, but I'm just going to replace services with builder.services. And now we've set up our IOC container. Next up, we want to set up our request pipeline. So let's go grab that portion of our startup.cs and set that in place right here. And now instead of endpoints, I'll just map the thing directly. And one more thing, let's say app.environment. And now we have all of the pieces here. We know exactly what our application is doing. We can now go delete this startup.cs.
Wow.
Ooh.
Scandalous.
Yeah. Isn't that so much cleaner, so much simpler, so much less boilerplate, so much less, layers of indirection?
Yeah, it is nice to be able to explicitly see what is launching up at startup time. I think, especially if you're just trying to figure out how the whole web-based process works in .NET land as well. I guess my question is, what happens, or is there ever a time where you might want to stick with the startup file instead of migrating it all into the program file?
If you like that separation, if you like having all of your startup pieces kind of hidden away, then you might want to stick with that startup. Or if you just don't want to futz with it and it's working, then you don't need to upgrade to this. I find it cleaner. I find it easier. But if you like the old way, then by all means, stick with what you know.
Cool. But yeah, like that there's options though. It's really great.
Yeah. Now next, let's kind of look at a cheater method. And this only works for program.cs, but it is so cool. We always have a public class program. We have a public static void main, and that's kind of it for this program CS. So we can remove them. Now this only works for program.cs, but now we only have the contents of public static void main. We don't have the class definition. And isn't that nice? We're not indented 8 squares anymore.
That is pretty nice. I know that does scare me sometimes. Like sometimes when you start like a new console app, for instance, using .NET 8 or C# 11, it'll just be like string equals hello world. That's it. No main method. I'm like, what do I do?
Yeah. Where does this go?
Yeah. Like really? Like, and it runs,
Yeah.
and it's like, ah.
And it still builds and runs just fine.
Nice.
Now we've upgraded a project that includes Razor Pages and MVC and Web API, but this is a minimal APIs talk. Like, where's the minimal APIs?
Yeah. False advertising.
Let's build some minimal APIs. App.map get. Now, last time we just did our home page, but our home page is taken up by our home controller that does our home, our index view. So let's say /API/minimal. And we'll do that same thing where it's going to run this method. New message equals hello world. But let's pass in our name and do it this way. So let's go name, and if you don't pass it, world. And that's our thing. I'm going to just add a little bit of white space so that we can see it. There's a minimal API, and minimal APIs, Razor Pages, Web API, MVC, they all play really well together. So we can see that we now have a fourth paradigm for doing this. So we can even do some more. Let's say app.map post. I want to go to /API/minimal/1, 2. And I want to take in string 1, or let's say int 1, return that new message here. And I'll say message is 2. And let's say ID equals 1. And oh, I forgot a comma. That's why I was mad. There we go. Cool. So we can see that we can use attribute routing in the same way that we could do that with MVC and Web API. I'm passing in these 2 parameters and I'm using them here. To that end, let's put an ID equals, I don't know, 3 there. Now that's really cool. We have these really concise Lambda functions making this happen. But what if we want to do more? Let's say app.map put, And I'm going to take in /API/minimal one, or I'll say ID in this case, int ID, object body, and more stuff in this method. So I'll say bool validate equals true. So, do your object validation. Then, or if not valid, then return this dot bad request, and otherwise save to database and return this dot OK. And I'm going to say new ID equals ID and message equals and data equals body. Now, I could definitely attribute this about where I got it. I could say from query or from body, but by default, it will just do it for us. So I tend to leave them out. Gotcha. Cool. Some minimal APIs.
Awesome. And you do have a question in the chat real quick. Oh, yeah. Before we get into more of the APIs. This is kind of going back to the whole you can delete the main method and all of that to clean up a little bit in the program.cs file. So if you're emitting a class in main, what happens to namespaces? So if you wanted to add a specific namespace to the program.cs file, do you need to add it to a configuration file?
Ooh, yeah. Oh, looks like it pulled in that. I could just say namespace site, and it will do it that way. Oh, awesome. Nope, I can't. Oh. I'm getting an error there. That is a good question. I've never needed to worry about it. By default, it puts it in a namespace that matches your project, and that's usually been sufficient for me. But if you do need to very specifically put it in a namespace, there is syntax for that.
Cool. Good questions, y'all. Keep them coming.
Yeah, that was awesome. So here's my minimal API. And if we build it, we see everything's great. Well, kind of. This. In our controllers, this worked out great. But what is this here? Well, it's this Lambda method. And of course, this Lambda method doesn't have a .badRequest method on it. So how do we do that? Well, there's actually this really cool static class called results that allows us to be able to do that. And the results class defines a whole lot of methods that they're actually extension methods. Go to definition, there we go, that return this iResult interface. And so I have accepted, okay, bad request, login, all the different things that you expected to see inside this in controllers is now in results. And this iResult interface is actually really cool. Go to definition, and basically you just need to have an execute async that sets whatever you want on the response. So you can build your own. One that I like to build is setting the status code and returning a JSON result. I think they've added it now in .NET 8, but back in the day, you could either set a status code or return an object. And so there was times when I said, well, I really want to say status code 500, but I want to return an object there. And so I created my own extension method here to be able to return a status code and a results object. So all of the ones that we're used to, bad request, we can now use results to do that.
Neat.
And now it'll build just fine.
That's a pretty nifty trick. Shoot.
Yeah. Well, now I want to add a little bit more structure to this. Let's create a new object, and I'm going to call this minimal model. And now with this, I could definitely use a record. public int ID get set, public string minimal class for now equals empty public data, nope, minimal model data get set, and file scope namespaces for the win. Woohoo!
Woo.
Now that I've got this minimal model, let's come back in here, and instead of returning an anonymous object, we'll return this, which means I get to do this. We'll make this a minimal model. I'll cap that. We'll take in a minimal model. Now we've got object validation, which is really excellent. And now I have a little bit more structure to my system. So now I can do things like put validation attributes on my object. Oh, that needs to be an int like there. There we go. Cool. So now I've got a little bit more structure in my minimal APIs.
That is great.
And the cool part, yeah, we use minimal APIs and Razor Pages and Web API and MVC all in the same project. They're not mutually exclusive. Now, if we come back to our code, we can see that we live coded upgrading to .NET 8, adding file scope namespaces, global usings, implicit usings, the new builder. Let's take a look at testing. Now, I'm going to just open the other project because that'll save us a little bit of typing here. Mm-hmm. Let's open up the testing project and take a look at how we might test this. Now, if we're testing our weather forecast controller, we can write a unit test that just, I don't know, call test that will create a weather forecast controller and then call the get method. And we don't know how many, we don't know how random will work, so we can't validate the temperatures that we get, but we know that there will be 5. Now, I like this assertion scope here inside of Fluent Assertions so that we can run all of our validations, all of our assertions without exiting. Have you ever done that where like you commit it and the first assertion fails, so you go fix that code and then you commit it again and then the second one fails, and about the 5th build in, you're like, can you just run them all? So assertion scope works out great there.
Neat.
The other thing that I like to do is you could say assert dot equal actual expected. Wait, no. Expected goes first and actual goes, no, I think I had it right the other. I spent a real long time trying to debug a test once because it said expected 5 and got 7. And I debugged the test and I'm like, but I got 5. So it worked. Well, I actually had actual and expected backwards.
Oh,
and so
frustrating.
So the other reason that I really like Fluent Assertions is you can say actual dot should dot equal expected, and there is no ambiguity about is it the thing or the other thing, did I get it backwards? It's really cool. So I've got Fluent Assertions.
A lot more
I'm also using XUnit here, although you could use NUnit or MS Test, all are fine. And now our weather forecast controller takes a dependency. Now, the weird part is that, okay, we're not using this dependency. It might be easier to just delete it, but let's not do that. Let's create a new thing. So I could say ilogger of thing equals new, I don't know, fake logger, and start to build. Now I have to, well, let's reach out for a mocking library. Now I'm going to use MOQ or MockU, mock, and I'll just create a fake ilogger of weather forecast controller. I could use end substitute as well. And then I'll just pass in that object. Now, what if in time this weather forecast controller takes a ifoo? Now, my unit test fails, or my build fails, not because my unit test changed at all, but because the dependencies changed. Now I have to var foo equals new mock. I am so tired of fixing all my tests. Well, how did we solve this in the regular code? Go ahead.
Oh, no, I was just saying, yeah, that is definitely frustrating. Every time I have to test something in dependency, I just like, here we go. What fun we shall have. So,
yes. Well, what's really cool here in our regular code is we have our IOC container that just kind of fills in all the gaps. Could we use that with tests too? Well, here is AutoMocker. And AutoMocker is an IOC container for tests.
ooh.
And so the cool thing is you can just create this IOC container, and then you can say, I want to use this dependency, and I want to use this dependency, and it will just fill in all of the dependencies. And then when you say create instance, it will use all the fake dependencies that you've created, but it will also invent all the other dependencies that you don't care about. So I'm going to switch over from this methodology here to this methodology here, where I create that new IOC container, and then I get the IOC container to create me a weather forecast controller. And now I don't need to worry about what gets passed into this thing. If you add more parameters to the thing, my test still passes. Cool. So we built a unit test. And the cool part about this unit test is that now we can just call the thing and do the stuff. But this isn't running the full request pipeline. This is only calling that one method. Well, what if we have authentication, or we have a middleware that fills or caches things? We need to be able to flex that full process. And so typically what we do here then is we go find an available port, start the web server. Now we have to get our test to be able to connect on that port. Then we have to remember to stop the web server. There's a whole lot of moving parts in an integration test that just kind of makes that clunky. What if we could build an integration test inside of ASP.NET? So here we're going to create a new instance of this fixture, this site app fixture. And this site app fixture is just descends from Web Application Factory of type program, our program.cs here. We can choose to override whatever we need to in this environment. So for example, we could go look for our data context and remove it and swap it out with an in-memory data context. Whatever we need to do to be able to set up our environment for our tests, we now have this fake instance of our application. Back in our integration test, let's grab an instance of that application, and then we can say create client. Now this is an HTTP client, the same HTTP client that we use in our application for just making web requests. So let's go connect to that API weather forecast. Now, yeah, I could say read as JSON and avoid this, but I kind of like getting the body and then deserializing it and kind of taking a look at each of those steps. If one of them failed, I know exactly which step failed. Now, I don't know how many what the weather forecasts are, but I know that there's 5 of them. So we just made a web request using HTTP client the way we normally do, and now we can validate the results. We have an integration test that doesn't work through ports. It works completely in memory, but it runs the full request pipeline. So you don't have to futz with, do I have this? Do I have a port? Which port can I connect to it? Is there a loopback adapter? All of that just kind of melts away with this mechanism of just creating this fixture that allows us to do that test.
Very nice. Far less frustration, it seems like.
Yeah.
Goodness.
Let's unit test our minimal API, or integration test our minimal API.
Oh, quick question about the AutoMocker. Is it compatible with most major testing frameworks? So like MS Test, NUnit, XUnit, all of that?
Yes, AutoMocker creates mock instances, MOQ instances, but there is a similar methodology for auto-mocking with end substitute. And so that's just, when you say create instance, that's an actual instance. Or if you say use, then that's a mock instance. And so, yeah, in this case, I'm using it with XUnit, but you could use it with MS Test or NUnit as well.
Awesome.
Same thing with Fluent assertions.
Good stuff.
Yeah. So let's just call /API/minimal. We'll pass in name of test. And so we want it to say hello test when it's done. So we'll just run that test. We could also do a test with a post where we're passing in a post body and deserializing it. So it should say hello foo and 5. And so now we can do these integration tests with our minimal APIs, running the full request pipeline and validating that all of our systems work together. So let's build this, and we see that we've got a failure.
No. Uh-oh.
Program.cs is not accessible. Well, program.cs is this auto magic class that we built here. So, I want to come up here into the public class, but we don't have the, somewhere it says private. And how do I modify this thing? Well, it turns out it's actually not that. It is private. It's private partial class program. That's how it defines it internally. And so I can implement the other half of that partial class, and I'll make this one public. That is such a hack. So let me comment it. Public to be testable. And now I know why I did that. Okay. I implemented the other half of the auto-generated class so that now my build will succeed.
So does that problem only arise when you're dealing with testing, or are there other scenarios where that could happen and you might need to add in the partial class?
I hit it most of the time when I'm testing because I don't usually instantiate this program.cs. But there are other times when, hey, I just want to instantiate this thing. You could do friends visible to in your assemblies. You could, it gets a little hairy. This hack is the easiest way to get access to that.
Cool. Seems like a pretty easy hack. So
yeah. So now it works. Let's come here into the test window. We'll open up the Test Explorer. I have that down here, and let's run all of our tests. Now, if you want, you can come here into this dropdown and you can say run tests after build, and that will run all the tests anytime you build. There is a thing called live unit testing, and that's a little bit different. But if your tests run really fast, this could be perfect. Now, in this case, I'm going to run them manually. So I kicked them off, and let's zoom in a touch and see if we can get our test to run. Ooh, excellent. We've got passing tests. Yeah, so we have not only our unit tests running, but we also have our integration tests. We know that our minimal API works as expected because we've been able to validate it end to end.
Perfect.
Yeah. Now let's go back to our other solution and let's take a look at this. Now I've got this minimal API, and that's interesting, but let's imagine that I want to now add a new entity to my entity framework. And so I want to create those get, put, post, and delete methods. And so of course I'm going to put mine right here at the end, and you're going to create a similar PR and put them at the end as well. And now we hit a merge conflict. My minimal API and your minimal API. So can we create an abstraction that won't make this file, I don't know, 5,000 lines long? So let's come in here and I'll create a new folder. I'll just call this, I don't know, APIs. I'll add a new file. Let's call this minimal.cs. Oh, haha, it's already there. Public class minimal. I'll file scope namespace that, namespace site.apis. And let's move this content into there. So let's grab that and put it here. So I want a get method that does this. So let's say public minimal model get. There's that. I'll do the same thing with post here. Public minimal model post. Public I results put. And let's move this one there too. And now that's not a lambda, it's just a thing. So let's now public void init, and I'll take a web application. And let's rig it this way. Let's say app.map get to the get method, and the post to the post method, and the put to the put method. And now I can come back here inside program.cs, and I can say var minimal equals app.get required services.get required service of type minimal, and then minimal.init app. Or I can even one line it and say .init app. Oh, I need a using. Let's come back here to our global usings and say global using site.apis. File scope namespaces are amazing. Cool. Now my pull request and your pull request, they may conflict, but they only conflict with that one line. So it's really easy to do mine before yours or yours before mine. Maybe now we sort this by something, and that gets us in an interesting place.
Great.
But if we look at this minimal, this kind of looks like a controller.
Yeah, it does.
I think in this case, we probably ought to just use a controller. That's the right solution to this problem. We went in the wrong direction. Yeah, we should just do controller base and get rid of this whole init thing, and that will get us to the right solution.
Cool.
This enterprisey application with lots of models and lots of methods is not the right solution for a minimal API. It's the right solution for web API. Let's take a look at a different solution that is the right solution for a minimal API. Now, in this project, my requirement is just a little something. Maybe I just need to host some file on some URL. Here's my interesting config, and I just want to post it. Or I want to accept a post from my website and send an email. Or I want some little middleware that will accept a webhook and do something. For these really, really small tasks, this is the right size for minimal APIs. So you'll notice here there is only one CS file in this entire solution, and it is right here. And this is 46 lines that includes that hack for testability. And it does all of this task of getting this config file online. So let's run it and take a look at how this runs. Now, the cool part is our task is just to get this, this JSON file online. And so we've done that. But a good API also has health checks and error handling and not found handling. So let's take a look at how those work too. Yep, we've got Swagger. We can run our interesting config, and there's our interesting config file. How did we do that? Well, I'm going to go read that text file. I'll deserialize it into a strongly typed record class that I have defined here at the bottom. So I know that I've got a real thing. I'm going to throw if it's null. I definitely want to error out instead of starting up and not being able to run correctly. And then I'll add it into my IOC container. Now I've chosen to add these curly braces just so I can't cheat and reach in to grab this JSON file. But then I have my map get here that will just take this out of the IOC container. I could definitely tag it as from services if I wanted to, but it's just going to go grab that interesting config file and host it. But with any good web API, we do want to have error handling. So we do want to make sure that we get a 500. Well, in our base template, we have this exception handler to /error. So we'll just map /error to return results.problem, a 500. We can also take a look at not found handling. So let's go to not a valid page, and we get a 404. We see in the network tab, it really is a 404 there. How did we do that? Well, we just grabbed everything and we returned not found. Now, when I originally did this, I wasn't returning a JSON object, so I just got Chrome's default error page, and I'm like, oh, I'm not connecting. So I chose to return an object. But we also want to do health checks. We want Docker to the Docker container to fail, and for Kubernetes to notice that this container is not online. So we have this health check here. How did we do that? Well, we've got this add health checks here, and we mapped that health check to the /health URL. So now in our microservice, in 46 lines of code, we have our interesting config hosted. We have health checks, we have Swagger UI, we have error handling, we have not found handling, we have Swagger, all of the features that we would want in a microservice in one C# file in this project. This is the right use case for minimal APIs. If you have an enterprise application with lots of models, upgrade to Web API. That is the right solution for the job. If you have an even smaller thing, you could upgrade to Azure Functions, where you don't need to even worry about the HTTP context. But if you have just that little niche where you need just a little bit of config or just a little function, then that's the right use case. Upgrade to minimal APIs. And we now have a fourth hosting paradigm inside of ASP.NET. Razor Pages, MVC, Web API, and now minimal APIs. None of them are deprecated. None of them are going away. Find the right tool for the job, and you can solve anything with ASP.NET.
Awesome. Well, that was a lot of really cool content and really nice strategies to clean up your code and also just to better organize things in a way that might suit your needs a little bit better depending on the scenario. So thank you so much for sharing that, Rob. And I know we're short on time and there's probably more questions in the chat, but where can folks go to learn even more about this?
Yeah,
oh,
the code for this talk is right up here on GitHub, github.com/robrich/minimal APIs ASP.NET. But an easier URL to go to robrich.org, robrich.org, click on presentations, and there's the code to that we just did. And here's the link. If you find a question, if you're watching this later and you want to reach out, hit me up on the socials, and I would love to dig in farther.
Awesome. And I heard whispers in the chat that you also have a book that people could check out.
Yes. I got to work on this book. It's really cool. Pro Microservices in .NET 6. It's just as applicable to .NET 8. It's a great book for a architecture strategy of how you can architect microservices. And I've also gotten to work on other things. Another book, I run some user groups, and Microsoft's given me some awards as well. It's fun to be able to serve the community.
Awesome. So yeah, lots of avenues to get in contact with Rob and to learn more about some really cool content that you shared here. So Rob, I know that was like the short version, but thank you so much for sharing all that really meaty and very useful information. I think the fans are into it. So definitely go check this out and start adapting your applications for minimal APIs. That's really cool.
Yeah, it's a great new tool that we have in ASP.NET. It's so much fun to be a .NET developer right now.
Yeah, absolutely. Lots of big changes happening all the time.
Yeah.
Right. Well, thanks again, Rob, and thanks, viewers. You know where to find him. You know where to find me. Reach out to me on Twitter, X, whatever. Or you can comment in the episode itself, and we'll try our best to help answer any remaining questions there, too. So thanks, y'all. And until next time, happy coding.